Figure 19.3 CollectionTest.java. In this example, we're going to demonstrate some basic collections capabilities. We're going to start by using the list interface, which allows you to interact with any data structure that is a list. And in particular, the list data structure we'll be using in this example is the array-based list data structure called ArrayList. We'll also use the collection interface to interact with our collection, showing you some of the basic capabilities of all collections, and then also the iterator interface as well. An iterator is a way of walking along a collection so that you can touch every element of the collection. And in fact, the for each statement, the enhanced for statement that's built into Java, is capable of using iterators on a collection to help walk across the collection one element at a time. So let's take a look at our collection test class. We begin at lines 10 through 13 with two private final static string arrays, one called colors and one called remove colors. And you can see for the first string array that we've got the strings magenta, red, white, blue, and cyan, and for the second string array just red, white, and blue. Now, in this example, when you look at main, all the way at the bottom here, you'll see that all we do is create a new object of our class CollectionTest, which is going to call the constructor to initialize and perform the tasks of this class, and then when the constructor finishes, main will terminate and the program will be done. So let's take a look at our CollectionTest constructor. We begin at line 18 by creating an ArrayList object. So you'll notice the use of new ArrayList on the right side of the equal sign here. And to the right of the word ArrayList, we have a set of angle brackets, which is the Java generics syntax in which you can specify a so-called type argument that indicates to the ArrayList what type of objects you intend to be storing in the ArrayList data structure. And notice I said what type of objects. You cannot use primitive value types like int and float with the generic capabilities. However, you can use their type wrapper classes like integer with a capital I, and then use Java's built-in boxing and unboxing capabilities to allow a primitive value like the number 7 to be turned into an integer object that's called boxing, and then to be returned back to an integer value, an int value, when you need the value from the collection. So you can still use primitive values with your collections, but this type that you store in the collection has to be one of the type wrapper classes instead. So in this case, we have an array list of strings, so we're only going to allow strings to be placed into the array list. We can designate the size of the array list. In this case, we chose not to, but array lists can grow dynamically, so we don't actually have to specify the size of the array. If you know in advance what the number of elements is that you'll be processing, it would be better to pre-allocate that amount of space, because then you don't have to suffer the overhead of allowing the array list to grow dynamically. Now we're taking the new ArrayList object that's being returned from the new operator at line 18, and we're assigning its reference to the variable list, which is not declared to be an array list, but rather just a variable of the list interface type. Now the list interface type is implemented by the ArrayList class, and in particular the ArrayList class, when we say to store strings, is implementing list of strings. And by using the interface type for our variable, we actually make our program a little bit more flexible. We can very easily change to a different list implementation by just replacing ArrayList here on line 18 with, for example, linked list, and we can still process a list of elements in the program. So it's actually a good programming practice to use the interface types wherever you can, so that you can change your class implementation details very easily later on if you need to. We do the same thing here at line 19, where we create another new array list of strings, and we assign it, in this case, to the variable remove list, also a variable of type list of string. Now at lines 22 and 23, we populate the list object by adding the color strings to the list. So this is one of many different methods that we have available to us for lists and for collections in general. We're taking a string from the color colors array, and we're adding it to the end of what's already in the list. Well, initially the list is empty, so the first item added becomes the first item in the list, and then the remaining elements of the array are added behind that in the list. Separately, at line 26 and 27, we populate the remove list by adding the colors from the remove colors array to that list. Then we go ahead and print at line 29 array list, and then we show you the contents of the list array list. And the key thing that we're doing here is demonstrating to you that you can use indexed looping if you wish to iterate through a list data structure. So you'll notice that we have an integer called count that represents the counter that helps us iterate through the list, and we're going to keep looping as long as that counter is less than the list's size, so the list knows how many elements it has at all times, and we're going to increment by 1 each time. And in the body of this loop we're going to print a string, and the way we're going to obtain the string is by saying to our list, get us the element at position count. So you can literally iterate through the list using indexing just like you do for an array. However, unlike some other programming languages, Java does not allow you to do what we call operator overloading, where you could actually define the square brackets operator to work with something like a list. So instead of using an operator to obtain each value, we use a method called get to obtain each value from the underlying list. Now I'm going to stop there for a moment and run this program so we can look at the output up to that point. And you can see that initially when we output the array list, it's got the 5 strings magenta, red, white, blue, and cyan. Now the next thing we're going to do here at line 36 is invoke our own remove colors method, and we're going to hand it both lists, and we're going to remove everything that's in the remove list from the list array list. So the red, white, and blue strings are in common, and everything that matches we're going to remove. So let's go ahead and take a look at our remove colors method. And you'll notice right away an interesting thing about the parameters. We've not declared the parameters as lists, but rather as collections of strings, because the functionality that we're going to use in the body of this method is actually functionality that you can use for anything that is a collection. So when you're designing a method that's going to operate on collections from the Java collection framework, what you generally want to do for the parameters of that method is use the simplest interface you can to get the functionality that you want, and by doing so you often enable that method to be used with many more collection types. So many different collections directly or indirectly implement the collection interface, and what we're saying here is that this remove colors method requires 2 collections of strings, one which we'll call collection 1 and this second one which we'll call collection 2. Now all collections have an iterator method. An iterator is an object that allows you to walk along a collection, and the type of the object is going to be iterator of whatever type is stored within that collection. So in the case of a collection of strings, when we call the iterator method, we're going to get back an iterator for iterating over strings, and we've called that variable iterator. Now the iterator itself, if you were to look it up in the online doc set, has a couple of interesting methods, one of which is hasNext, which returns a boolean indicating whether or not there are more elements to iterate through in the collection. Now initially the iterator is actually positioned just before the first element, and you don't actually get to the first element until you invoke the next method on the iterator. So this just tells us if there's more elements to iterate through. If there are, we go to the if statement in the body of this loop and we say check to see if collection 2 contains whatever iterator.next refers to. Iterator.next first moves to the next item in the collection, then it returns a reference to that item. So if collection 2 contains whatever that item is, we're then going to say to the iterator, remove from the underlying collection whatever is at that current location that the iterator is referring to or pointing to. So if the string from collection 2 if the string from the first collection is in collection 2, then we're going to remove it from the first collection using the iterator. So once we've finished this method, when we get back to our constructor and then start to print out what the array list contains after calling remove colors, in this case we chose to use an enhanced for loop to iterate over our list to demonstrate to you that you don't need to use indexed looping and that the enhanced for statement already knows how to operate on the collections from the Java Collections framework. So I'm going to iterate using strings from the list collection, and for each string in the collection I'm going to output that string followed by a space. And when you take a look at the bottom of our output here, you can see that only magenta and cyan are left in that list because of the fact that we removed elements using the iterator object. So everything that you saw in this example pretty much applies to most Java Collections classes that you'll ever not implement but interact with in a program.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.